wrote it down, but we have talked about how the more rectangles you have, the more accurate your area will be. So now we're finally going to come out and say it. To calculate the true area under the curve instead of just approximations, you would have to essentially divide it into n intervals and then do the limit as n goes to infinity. So we want to essentially turn that into an infinite number of rectangles, and then that limit would give us the true area under our curve. So let's go back to this example. Wasn't that the very first example we ever did? We did the over and under estimate with 5 rectangles, then we did it with 10. We're going to find the true area under this curve now. So we had some approximations, now we're going to find out what it actually is. To do that, the first thing we need is to find the change in x. So change in x is just your ending minus your beginning divided by n, because I'm not telling you how many rectangles this time. So that would be a 3 over n. Alright, then we need to find our x sub I. This is essentially our formula for how we get the points. You know, when we were just plugging them in, we would have like a change in x of 3/5. So our first point was 3/5 and 6/5 and so forth. So we need a formula for that. To do it, we have to take our starting point, which in this case was a 0, plus the change in x is how many times or how much you add each time, right? So we'll have our starting plus our change in x, and then we need to be able to add that 1, 2, 3, 4, 5 times, so we put the I with it. So in this case, this just turns into a 3 over n I. Okay, so now we are going to find the sum. I'm just going to do the sum first, and then I'll do the limit at the end. You can write the limit on every step, it doesn't really matter. When we did those rectangles, we had to add up the areas of every rectangle. How do we find area? Length times width. Now all of them have the same width. It's that change in x. So my width is that 3 over n. The length, or the height of the rectangle, we found by taking the x value we were using and squaring it, right? Plugging into that formula. So this would be times 3 over n I squared. Okay, we did this yesterday, but we only did it with the 10 rectangles. Do you guys remember that? So we had the same formula yesterday, but now we're going to do it with n rectangles. So if we clean this up, so if we square this, we get 9 over n squared I squared. We know that the I is really the only thing we're adding up. These are just coefficients, so we could pull those out. So 3 times 9, this would be 27 over n to the third. You can pull that out in front of your sum if you want. And then don't we have a formula for adding up I squared? So the I squared formula is n times n plus 1 times 2n plus 1 over 6. This is the thing I need to do the limit of, as n goes to infinity. I'm going to clean it up as much as I can first, just to save some trouble later on. You know, looking at this, I could definitely cancel one of these n's right away. 27 and 6 you could reduce to 9 and 2. So then we need to FOIL this out. Can I FOIL and distribute my 9 at the same time? So this would be a 2n squared times 9, so 18n plus 9 all over 2n squared. Finally, I think what I'm going to do is just put each term over the denominator, since the denominator is one term. So 18n squared over 2n squared is 9. 27n over 2n squared would be 27 over 2n. 9 over 2n squared. So that is the formula. Essentially, now you could tell me the area if I had 5 rectangles or 10 rectangles or 20 rectangles. All you'd have to do is plug in your n here. But we want what in order to get the true answer? We need our n to go to infinity. So we will do the limit as n goes to infinity of this. And so the 9 would just stay. These, if you have a number over infinity, goes to 0. So our answer is 9. The true area was 9. If you look at the example 1, we did the over and under. Was 9 in both of those windows that we had? Yes. I think we even talked about how we could have averaged those to get an approximation. Did we get exactly 9 when we averaged them? No, but we got something close, like 9 point something. So it was in the ballpark. All right. Another one? So let's find the area under this graph from 1 to 5. So how would I find my change in x? Your ending minus your beginning divided by n rectangles. So my change in x is 4 over n. Then we need that x sub I. How to find where we're at any given point in time. To do that, you have to start at where? 1. So I have to do 1 plus our change in x times I. So it'll always be your starting point time plus the change in x times I. Okay, unfortunately, this one doesn't simplify anymore, so this problem's going to be a little bit uglier. It's much nicer if we start at 0. Now, let's do our sum. Always going to add up from 1 to n. We want the area of the rectangle, length times width. We know the width is 4 over n. The length, you have to take your x sub I and plug it into your formula. So this one's going to get ugly. You have 100 minus 3 times 1 plus 4 over ni squared. Okay, we have a lot of algebra to do on this one. We need to start kind of multiplying this stuff out as much as we can. This 4 over n, I'm not going to worry about it yet. So 100 minus. I have to FOIL this and distribute essentially a negative 3. Can I do that all at once, or am I going to lose you? I'll break it up steps. If I FOIL this, we get 1 plus 4 over ni plus 4 over ni would be 8 over ni plus 16 over n squared I squared. So now if I distribute my 3, Alright, 100 minus 3, those are like terms, that would give me a 97. I'm going to distribute that 4 over n now as well. So 97 times 4, 388 over n, minus 4 over n times negative 24 over n, negative 96 over n squared I, minus 4 times 48, 192, is that right? So now we can add this thing up. This first term doesn't have an I in it, so it's like a constant. What was the rule for when you add up a constant? You multiply it by the number of times you're adding it, which is n. So this is 388 over n times n, because you add it up every time. Minus 96 over n squared. What's the formula for I to the first? N times n plus 1 over 2, minus 192 over n cubed, I squared. The square formula is n times n plus 1 times 2n plus 1 over 6. Okay, this is definitely not pretty. Have I lost anybody? So we're still just doing algebra to clean this up as much as we can, and then once we decide we can't clean it up anymore, what are we going to do? The limit. Alright, so I could cancel an n here, cancel one n here and here. So that gives me the 388. Okay, 96 divided by 2, we could reduce that as well, can't we? What would that give me? 48. So let's distribute, well, I'm going to write it like this. Now you could go ahead and simplify that more. I'm just trying not to skip too many steps at once. Okay, 192 divided by 6. Thank you. And I'm going to go ahead and FOIL that. Okay. So we are doing the limit as n goes to infinity. We have 388. This would be at 48n over n, so that's in minus 48, minus 48 over n. I'm going to distribute my negative 32 and divide by n squared, so that would be a negative 64n squared over n squared is negative 64. Negative 96n over n squared, so negative 96 over n, and negative 32 over n squared. Now, if n is going to infinity, anything with an n on the bottom turns into 0, because we're doing our limit. So if we have 388 minus 48 minus 64, 276. And that is the true area under the curve. Okay, that one was a lot more work Partly because the equation had two terms in it instead of just a nice x squared, largely due to the fact that we didn't start at 0. It's much, much nicer when we start at 0 with these. Questions on that one? Do I need to do another example like this? The last example I have on here for today is a little bit different. Instead of giving you a formula, I gave you a table. So it tells us the odometer on our car is broken and we need to estimate the distance we have driven over a 30-second time interval. Okay. We take speedometer readings every 5 seconds and record them in the following table. Estimate the total distance traveled. Okay, first of all, since it was a class example, I felt like I could throw something uglier at you than maybe I would have done on your homework. I wasn't very nice. Do you guys notice a problem with the information I've given you? Our time is measured in what? Seconds. Your velocity is in what? Miles per hour. So we have to change that. Our units need to match. Now we can change our velocity to miles per second, but that's going to give us some really small nasty numbers, isn't it? Do you want to go to maybe feet per second? That would probably be a nicer unit. So I am going to, probably wouldn't make you do this on your own, but since we're doing it together, I figured it wouldn't hurt anything. I'm going to change my velocity to feet per second. Okay, this is not that hard to do. If you have miles per hour, we want feet per second. Okay, we have to think, how many seconds are in 1 hour? There's 60 seconds in a minute, 60 minutes in an hour, so 60 times 60 would be 3,600. So 1 hour is 3,600 seconds. If I want miles into feet, 1 mile is 5 tomatoes, 5280. Okay, so what we essentially need to do is just take each of these numbers, 5,280 divided by 3,600. Okay, we could reduce that, but we don't have to. So essentially you'll take the velocity I gave you, so 17, times 5280 divided by 3,600, and that will convert it into the unit we need. Let's just round to the nearest whole number for the sake of simplicity. So this one would come out to be 25 if I round to the nearest whole number. Next one is 30.8, so we'll round it to 31. 35.2, so we'll go to 35. 42.5, so 43. 46.9, so 47. 45.4, so 45. And this one, 41.0, so 41. So that right there is a step I probably will not make you do on homework or test or quiz, but we did it just for fun. Now my units are all consistent, so we can estimate the distance. Okay, distance is rate divided by time, right? So we can essentially think of this like our previous problems. We can estimate it two ways. We have like a time frame. So if I wanted to estimate how far we drove in the first 5 seconds, was I going the same speed at the beginning and end of that 5 seconds? No. So I could either give you an estimate based off the time at the beginning, so assuming we're traveling 25 the entire time, or I could give you an estimate based off the ending time and assume we're traveling 31 the entire time. Now, will either of those be accurate? No, but the true answer should be somewhere in between them, right? Just like the over and under approximation. That's essentially what we're going to do. So we are going to do it once from the velocity at the beginning, and then we will do it once from the velocity at the end of our time interval. So distance is just rate times time. So between 0 and 5, how long were we traveling? Just 5 seconds. And our rate, if we're basing it off the beginning, we would say we are going 25 the entire time. The second time frame we would do from 5 to 10. So what's the length of that time interval? 5. And what speed would we assume the entire time? 31. Okay, if we went from 10 to 15, the length of that time interval is 5. What speed would I assume? 35. If you recognize that all these are a distance of 5 apart, you could have just pulled the 5 out in the front too, either way. So then, let's see, we've done 0 to 5, 5 to 10, 10 to 15. So between 15 and 20, it's a time frame of 5, assuming a speed of 43. Between 20 and 25, it's a distance of, or time frame of 5, assume the 47. And between 25 and 30, could assume the 45 the entire time. So if I just base everything on the speed at the beginning of that time frame, we would estimate that we traveled 1,130 feet. The second way is to estimate it from the speed at the end. Now, since all these are the same distance apart, this time I'm just going to pull my 5 out. Then what y value, what velocity would I use each time? The ending. So essentially I'll use 31, 35, 43, 47, 45, and 41. I just won't use the 25. And this one estimates it at 1,210 feet. If I asked for your best guess, what would you do? Average this. Now, that's probably not exact, but it should be pretty close to the true answer for how far we traveled. Okay. Any questions there? So remember, we have a quiz on Monday. I'll probably take a few minutes at the beginning of class Monday to review things, but you might look over. I won't have time to spend, 20 minutes reviewing or anything like that. So it's over the antiderivative. Remember, you always put your plus C on them, unless I give you the information to find your C. And then over the stuff we've been doing, so summation notation, those summation formulas, like the formula for I squared, I cubed, over and under estimates, and then what we're doing today. So today's homework is again a handout posted on Classroom. It is only 5 questions, so